Today we are going to add element in Min-Heap. Suppose this Min-Heap is given and we want to add 34. Suppose we want to add 34. Then what? How to add 34? Here this tree is given and suppose we add 34 here because this all are free, all are completed. This is complete binary. This is parent, this is children, this is parent, these are children, this is parent, these are children, this is parent, these are children. So we can add 34 here only. So we can add 34 here only. Then what will happen? Let's see. Because this is Min-Heap, this is Min-Heap, so it will go up because children's always be greater than the root, but this is greater, this is less, so it will go up like this. So 95 will come here, 34 will go there. Then again root is more, children is less, child is less, so again it will go up, it will go up. So 55 we can say will come here and 34 will go there. And again we can see here this is child is less and root is more, so again it will go here, 34 will come here and 35 will come here. Now we can see clearly that root is less and child is more. So this is completed. This is the complete process of adding the element in Min-Heap. So we can say simply now what will be the tree here. After this, tree will be like this, tree will be like this, root will be 10, then it will be 34. From here we can say simply it will be 34, it will be 42, it will be what it will be, it will be 35. So 35 will come here and 66 will come here. Here it will remain same, 50 and 72 it will remain same. Now what will come here? 55. So 55 will come here and here 96 will remain same. Here 87, here 88, here 57, here 52, here 75 and here 76, and the last element what is 95. So 95 will come here. Like that we can add 34 in Min-Heap. So we can say in the form of array also, the number of elements we start from root initially from this, not this. After that we will see how we can add in the array also. So 30 is the root and child are left child 35, right child 42. Then what will come? 55, 66, 55, 66, then 50, 72, 50, 72, then 95, 96, 95, 96, then 87, 88, 87, 88, then 57, 52. Oh, so this is 51, not 57, so it's not possible. So 51, 52, then what will come? 75, 76, 75, 76. Now what we want to add? We want to add 34, so we will write 34 here. We will do indexing now so that it will be more clear. Indexing will be like that: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and the 16. The new one is 16. So 16 parent will be 8, 16 parent will be 8, so it will go here directly on 95. So we shifted, we change 95 with 34 from here. So instead of 95 what will come? 34 will come and 95 will go here. Now the further root is 4th, so we will go on 4th. So 55 as we have seen here also. So 55 will replace by 34 and 55 will come here. Now 4th is replaced with 2nd because the fourth child parent will be 2nd. So 34 will come here, 35 will go there. Now it is on the correct place, so no replacement is required. Like that it will work. So we can say what will be the next array. The next array will be 10, then 34, then 42, then 35, then 66, then 50, then 72, then what will be here? 55, then 96, then 87, then 88, then 51, then 52, then 75, then 76, then 95. So in that way it will work. Now we can say indexing also. 1 2 3 4 5 6 7 8 9 10 12 13 14 15 16, all the elements are over. So in that way we can add element in the min heap.